Hello everyone, welcome to another episode of this Deep Learning with PyTorch series. So far in this series, if you are following this playlist, we have covered a lot of ground. Like we started with very basics of neural network, then we talked about CNN, and then we also talked about recurrent neural network with RNN and LSTM. And in this section, we will talk about graph neural network, right? Now, so without further delay, let's get started. So in this episode, we will basically talk about what is a graph and how we can define a graph, how using different techniques we can represent a graph which a machine can understand. Then slowly from the next episode onwards, we will talk about graph neural network, right? Everywhere, and also in recent one of the report, which is like State of AI report, which is published in 2021, it has been said that the graph neural network would be the hottest field of the AI research, right? Now let's take a few of the examples where graph data is present. Medical and biology field is one of the predominant area where graphs are almost present, because the molecules and the DNA protein interactions can be easily represented as a graph. That's why, like, for drug discovery, this graph neural network or the graph data is used heavily to come up with a new drugs. Then we have social networks, where like World Wide Web is another huge graph data example, and also the web graphs is also present, right? Then there are navigation systems like Google GPS, Uber, which uses graphs network to solve road networks or the navigation problems. And also in recent times, we have seen that the recommender systems is also using graph as primary object to provide optimal recommendations. So as you can see, like, the graph has a different varieties of application areas, and that's why, like, it's quite essential for you to learn graph nowadays and how you can use graph neural network to solve these problems, right? Now let's define how a graph is, right? How or what does a graph looks like? So graph is generally a collection of nodes and edges, and collection of nodes are generally called vertices, right? So for this example, we can see like there are four nodes, 0, 1, 2, 3, and each of the nodes are connected by certain edges. So we have vertices and also a collection of edges. So we have four edges here, like 0 to 1, 1 to 2, 2 to 3, and 0 to 3. And we can define the graph as collection of vertices and edges. Now let's talk about what are the different types of graphs, right? So generally, graphs are defined. We can classify graph as two types. One is directed graph, and another is undirected graph. So in case of a directed graph, the set of vertices are connected by directed edges, right? And in case of undirected graph, the set of vertices are connected by undirected edges. Now let's see with an example like how this looks like. So generally we use adjacency matrix to represent a graph where rows and columns are denoted as vertices. The values of these matrices can be defined as like this. So Aij, where, like, if there is a edge exists between j to I, so that will be 1, and if there is no edge exist, so that value will be equals to 0. Now this is an example of non-directed graph or the undirected graph. So here, like, if you see, there are certain nodes starting from A to F, and we also have a corresponding adjacency matrix. Adjacency matrices values, you can see, like, we have a edge between A to B, right? So that's why that corresponding value of A to B would be equals to 1. And also this is a non-directed graph, so we can also travel from A to B and also from B to A. So B to A value would be also equals to 1 in the adjacency matrix. But in case of adjacent directed graph, we can see, like, there are directed edges from A to B, so only you can travel from A to B, not from B to A. That's why the corresponding values are represented in that fashion. Directed and undirected graph, and you can use adjacency matrix to represent those each of these graphs, right? Now let's take an example and let's understand how the graphs are generally represented in terms of how the machine can understand this graphs, right? So caffeine molecule can be represented using graphs. So here is an example, like caffeine molecules can be represented as a collection of atoms held together by chemical bonds, right? And the atoms can be of different types. Different chemical elements also can be there, like carbon, oxygen, and nitrogen, and or hydrogen. So we can see like we have certain nodes here starting from 1 to till 14. So those many nodes we have, and each of the nodes are kind of represents a chemical element. And like, so for example, like C1 means that that node, the first node, is of type of atom is carbon, right? And there are also just can be of two types, single and double bond, right? So what we can see is we can represent this using three matrices. One of them is adjacency matrix, so that defines like how you can go from one node to another if there is a connection between two set of nodes. And then there is a node level matrix. So here in the node level matrix, what we are doing is we are kind of using a one hot encoding of the atom type. So for first row you can see like C equals to 1 and N equals to 0 and O equals to 0, because the first node is the type of that node is carbon, right? So that's why C equals to 1 and rest are 0. So similarly we have for each nodes we have a representation of with the help of one hot encoding, right? So that we generally call as node level matrix. Then we have edge level matrix. So edge level matrix is again one hot encoding of the bond type. So if between like 1 or 2, the two nodes, right, 1 and 2, if there is a single bond, we can see like in the image that that is a single bond. That's why the SB equals to 1 and TB equals to 0. So it is kind of a one hot representation of the bond type, right? Which is already we are also calling it as edge level matrix. So we have node level matrix and the edge level matrix and also the adjacency matrix. So with these three things we can represent caffeine as a molecule, and which can be represented as a graph, right? So I hope you got an initial understanding of how the graphs are working, and in the next video we will talk about graph neural network in very much in detail, and how we will see like how we can formulate a problem using graph, right, in case of like a neural network or a machine learning problem, right? So with this I will end this video. I hope you got an initial understanding of what does graph looks like and how we can represent, and in the next video onwards we will talk about graph neural network. So if you haven't subscribed this channel, please subscribe, and also share this content if you found this content as helpful to you. Thank you. See you in the next video.